Section 4.1, solving linear inequalities in one variable. So first thing, notice 3 is less than 7. That's a true statement, we all can agree on that. What about if we added something to both sides? For example, if we add 2 to both sides. Well, we'll still get 5 is less than 9. Still a true statement. What about if we subtract? So once again, we'll start with 3 is less than 7. Let's subtract this time. Let's subtract 9. And I'm just picking numbers here. 3 minus 9 is negative 6, and 7 minus 9 is negative 2. Notice we still have a true statement. So notice both of these are still true statements. So what that tells us is that we can add or subtract something from both sides, and it doesn't change the inequality. Just like we could add or subtract to both sides of an equation, and we were okay. So now we're going to do the same thing and look at multiplication with division. So 10 is greater than 8. We're all okay with that. What about if we multiply by a positive 4? Well, 10 times 4 is 40, and 8 times 4 is 32. We still have a true statement. So we still have a true statement. Alright, once again, starting with the true statement, 12 is greater than 3. This time we're going to multiply by a negative number, in this case negative 2. Negative 24 is greater than negative 6. Notice that's not true anymore, because negative 6 is greater than negative 24. So the key thing to keep in mind is when you're multiplying or dividing, and it matters if it's a positive, the inequality will stay the same. If it's a negative, you have to flip your inequality. Notice in this case, to make this a true statement, it would need to be like this. Notice the sign has flipped. So now we're going to solve our inequalities. We're also then going to graph our solution and write it in interval notation. So first we're going to solve these. And remember, it's just like solving equations, except if you multiply or divide by a negative, you have to flip your sign. Notice we only added and subtracted, so our sign doesn't flip. But now we are dividing by a negative, so our inequality is actually going to switch. So we have now solved it. We've got to write this on a graph. Remember, this is 1 and a 4. We want the numbers less than or equal to. So we have the equal, so we've got a bracket. And we want the numbers less than that, so we're going to the left. But then we also need interval notation. So that means we want all the numbers from negative infinity up to 5/4, but including 5/4. So we've got our bracket. Next one. Divide by negative 6. So on a number line, we want the numbers greater than negative 2, but notice not equal to, so we'll have our parenthesis. So we want all the numbers from 2 on up. So now we have a half. We can just multiply both sides by 2. Notice though this 2 was positive, so our sign is not going to change, even though this is a negative here. And we want the numbers greater than negative 8, so we'll be going this way. And it's not including, so it'll be our open parenthesis. So you have negative 8 to infinity. So now we're going to solve compound inequalities by graphing. And then for our answer, we need to write it in set notation and interval notation. So just like when we always graph, start with a number line. And I will typically draw them, but each piece below it, and then just write the answer on the number line so that we don't get confused. So this first one, when x is greater than negative 1, The second piece will be x is less than or equal to 3. And we want when we have both of these. So when do we have both lines? Because we want this and this, so you need both things. So we have both lines between here and here. Notice that the 1, this is not included in the 1, so we don't have both of them included, but both are included in the 3. So then for our solution, in set notation we have all of our x's such that x is between -1 and 3, where 3 is included. In interval notation, our low end point is 1, our high end point is 3. Now on this one, it's a little bit easier. Notice we want all the numbers between 0 and 5. 0 is included, so we want 0 up to 5, no more than 5. We need between those two. So our solution for set notation will be quite easy. We're just going to rewrite what's up there. But for interval notation, our low point is 0 included, high point 5 not included. Now on this one, let's look here. This first one, we want x is greater than or equal to 2. The second one, x is greater than 4. Remember, it's an and, so we want where there are both lines. And there are both lines starting at this 4, going to our right. So our solution, in set notation, it's x, and we want all the numbers that are bigger than 4. And in interval notation, we start at 4 and go up to infinity. Same thing, start with our number line. This first one, x is greater than -5. Second one, x is less than -8. Well, when we're asking where do we have both of these, where is there an x that fits both of these? And it doesn't fit anywhere, so this would be no solution. Now on this one, once again, you always start with your number line. This first one, we want x is greater than 3, or less than or equal to 0. But now notice, since it's or, if, for example, you or your friend go to the store, that means only one of you has to go. You can both go, but only one of you needs to be there. So for these, if there's or, it's where is there at least one line, one or more. Well, there's at least one line here and here. So how we write that, we still have an x, and so we want the x's that are less than or equal to 0 or greater than 3. In interval notation, we want all the way from -infinity up to 0, union with 3 up to infinity. On this one, once again, you always start with your number line. This first one, x is greater than or equal to 2. Second one, x is greater than 4. So where is there at least one line? Well, everywhere from 2 up has at least one. So our solution is all of our x's as long as x is greater than or equal to 2. And then in interval notation, everything from 2 on up. Now this one, once again, start with the number line. So we want greater than -5, less than 3. So what numbers fit at least one of these? Well, every number you can possibly imagine is going to fit one or the other. So that means all numbers work. All real numbers are going to work. So this means as long as x is a real number, it works. Or from negative infinity to infinity in interval notation. And now, notice we have to solve and then get into our graphing like we just did. When you have a compound inequality like this, it means this whole middle part has to be greater than 4, and this whole middle part has to be less than or equal to 8. So we'll break this up into two pieces. And we need this whole middle part to be less than or equal to 8. And then we'll just solve each of these. So now we get to here, so now we come back to our number line. And notice that 13 thirds, this is the same as 4 1/3. So we might use that to know which side of this 3 we get. So it'll go 3 and then our 13 thirds. And this left side we want x is greater than 3. On this green side, we wanted x is less than or equal. Notice it's an and statement, so we want where we have both lines, so it'll be from here to here. So our solution will be when x is between 3 and 13 thirds. And in interval notation, from 3 to 13 thirds. Same idea on this one, we've got to break it up. So we'll have this x plus 2 is less than negative 1/3 x. And this negative 1/3 x is less than 1/2 x. If we start with our red side, we can subtract an x from both sides. And then divide by a negative. Remember, when we divide by a negative, our inequality sign flips. Coming to the blue side, if we add over 1/3 x, divide both sides by 5, 6, we still get 0. Remember, we still have and. Now if we look at our red, we wanted x is less than this negative 3/2. And our blue, we wanted where x is greater than 0. Notice once again, there's nowhere that we have both of those. So our solution is actually, there's no solution. Now this one, it's already broken up into an OR statement for us, so we just solve each of these individually. So this first one subtracts 7 from both sides. On this second one, it'll be some distribution. Now, once again, we've got to draw our number line. Our green side, x is greater than 0. Our blue side, x is greater than or equal to 3/11. So it's an OR, so it's as long as we have one or the other. So our solution is from 0 up. So in set notation, it'll be anything where x is greater than 0. And in interval notation, it'll just be from 0 to infinity.